Okay, so we're gonna finish up 2122 today. Posting will be the quiz prep 2122. Hopefully it'll look at 23. On Monday, 23 and 24. Posting will be the quiz prep for 21 through 23. Because that's what the quiz will actually be on, 21, 22, and 23. Next Wednesday, 24 and 25. We're done with chapter 2. You get the review sheet for chapter 2. You take the quiz on 21, 23. Closed interval, 21, 23. Monday, the review. And then Wednesday, the 1st, we take the test on chapter 2. Bonus problems, office hours. You have until Thursday the 17th from 12:50. So tomorrow, yes. Okay, so today's the 16th, Monday's the 21st, right? So that's what I keep messing up these stinking dates. This is the 28th. Okay. So this will be the 30th. Thank you. So you have until tomorrow. Tomorrow, 7:30 to 8:20. Again, don't show up at 8:15 or show so you have enough time to do as much as you can. And then 12 o'clock, 12:50. I posted an announcement on October 8th with more details, which you better know how to do and where to find it. Over there, we have the notes from last week, solving linear equations, step by step, what you need to do. And we're applying it here to the last of our examples. We have 2 more examples from 2.1 to cover. And these little questions right here are actually number 28 from 2.2. This one right here is number 33 from 2.2. This is number 39 and then 36. And double check. There is good questions because of the fraction. 38 and 36. Because of the fractions, these are good examples. And this one right here is number 4. So actually, this one, and this one. Then we'll go back and do one of those and this, and then finish those. I altered the directions for 2.2. 2.2, the directions, they wanted you to write it as a function, let that function equal 0, and then solve it. Listen. First of all, I know that most people don't read directions. So even if I showed you all of that, you're going to go back and just solve it. So let's just go ahead and just solve the equation. That's the bottom line, solve it. But what they're actually getting at is finding x-intercepts and y-intercepts. When you let an equation equal 0, when you let a function equal 0, you're basically letting y equal 0. And anytime you have y equals 0, you're finding the x-intercept on a graph. Anytime a graph crosses the x-axis, anywhere, the y coordinate is a 0. So if you have an equation, some kind of function, some kind of equation, and you want to figure out what those points are, where does it cross the x-axis, You let y equal 0 and solve for x. To find an x-intercept, you're going to let y equal 0, and then you solve for x. Where does it cross the x-axis? And when you want the y-intercept is where it intersects the y-axis. If you're on the y-axis, the x-coordinate has to be a 0. Anytime you're on the y-axis, the x-coordinate has to be a 0. So to find the y-intercept, you let x equals 0, solve for y. When you want to find blank intercept, let the other one be 0. Okay, that's the bottom line. That's the bottom line. Another reason why I want to make sure I do these is in the back of the book, the answer to number 28 and number 33, they give the answer as a fraction, which, that's kind of like dirty pool. They're given the problem in decimal, and then they want you to turn it into a fraction. Well, that's fine. And honestly, you should be able to handle that. But I know I would lose more people than I would gain. So, if you can turn it into a fraction, that's fine. All you would do is take whatever you have, and I can show you. It just depends upon what you got. What you got to do here is I'm just going to go ahead and leave it as a decimal. Step 1, simplify both sides completely. Undo fractions if necessary. So if we were going to deal with fractions, we would change everything to a fraction right now, or just get rid of the decimals. Since it's everything to 10, 3.6, 8.2, 0.5. If you multiply everything by 10, that moves the decimal 1, and we're just going to get 36, 82, and 5. You'd have no more decimals, and then your final answer would be a fraction. Or I could work with decimals and turn my final answer into a fraction. Let's just get a decimal. Simplify both sides. You can't simplify this side because they're not like terms. And that's just a single term, so we leave that alone. So step 1's done. Step 2, gather the variables on one side, constants on the other. Now, I made sure that this was set up into 2 different colors. And I know it's small. Variable terms first, then do the constant. And that's what you really want to focus on. Variable terms and then the constant. You see what things happen when you try to do too much at once. So let's just focus on the variable. Either we're going to take the x's over to the right side, or we're going to bring the x's over to the left before you make a choice. Play out each scenario. Think it through. If I bring the x's over to the left, you would subtract 0.5x from both sides. Now here's the problem. 3.6 minus 0.5, that's not a big deal because that's going to be a positive 3.1. Positive. And then you have minus 8.2 equals, and then you have 0. And that's where I see mistakes. They forget to put the 0 there. In fact, when I see this happen and they decide to do this, they got 3.1x, and they don't know what to do with this side because they don't know what to put. So they just put the equals between these two. They just put the equals where they want, random. And they don't show the work for it, so of course they lose point. And the reason why they want to bring it to the left is because if I take it to the right, you have to subtract 3.6x. And now you're going to get a negative 3.1x. And they don't want to deal with the negative. So if I bring it to the left, you would add it, but you have both terms on the left. So you then have to add 8.2 to the right. You're going to have to actually make two moves. Bring the x to the left, take the number to the right. If I take the 3.6 to the left, you now have negative 8.2 on this side, negative 3.1x on that side. You just make one move. But unless you start thinking it before you do it, you won't get to that right answer. I see a lot of hoping going on. I hope it's this. I'm not sure what it is, but I see a lot of right now division. When you start dividing things. Because we're not practicing what to do next. Separate the variables. X on one side, constant on the other. So do you want to take the x to the left or bring it to the right? Let's do this. That's a 0 on the left side, negative 8.2 equals, this is negative 3.1 times x. And you have to do this. If you don't have an x here, you did not undo 3.6x. These are not like terms. First of all, you didn't do the same thing to both sides. That doesn't have an x, that one does. Okay. The other thing, what you actually did was you put on this side, if you have negative 3.6, you have 3.6x still. And now you have a negative 11.8 because negative 8.2 and a negative 3.6 is a negative 11.8. Those are the like terms. I'll save this as emphatically as I possibly can. Details frickin' matter. And if you plan on moving along, you gotta start paying attention to the details. You gotta force yourself to pay attention to the detail. And you gotta start writing neatly so you understand there are details here. If you want to get it right, you gotta start working it through one step at a time, cleanly, neatly, and with the details. You gotta force yourself. You gotta change what's not working into something that will work. And if you can't discipline yourself to do that, then that's where the struggle is. Okay? Now next. So all we have is a negative 8.2. So the variables and the constant are on separate sides. So step 2 is done. 2.5 variable did not cancel out, but it's still a variable. Now step 3, undo multiplication or division. This is negative 3.1 times x. So we divide both sides by negative 3.1. Not the x. The x isn't good because if you put the x here, now x is back on this side. And it's in the denominator. You want to leave x over here because that's who we're solving for. Over here, the negative 3.1 is reduced, and you have the x that we're solving. And over here, before the panic starts, it's just a negative divided by a negative. That's a positive. You see, you don't have to actually punch in the decimals into the calculator. And that's how you're going to get the rest of this. I know it's going to be a negative divided by a negative. That's going to be a positive. So I'm not going to worry about punching in the signs. I'm just going to punch in 8.1 divided by 3.1. Well, I'm missing. So 8.2 details. So since they're using the nearest 10th, all of theirs are in the nearest 10th. I'm going to round this to the nearest 10th. So x is equal to 2.64516.129. If I'm going to round my answer to the nearest 10th, I need to know it's in the hundredths place. So this 4, does it round this up to a 7 or leave it a 6? So x is equal to 2.6. I need to know it's in the hundredths if I'm going to round the 10th up or down, leave it alone. If I was going to round something at 100th, then I need to know it's in the thousandths place. And so on and so on and so on. So that's why I need to see all the decimals. That's why you don't round in the middle of a problem. If you round some of these intermediate values within the problem, your final answer is going to be off. So you don't round until the end. Number 33 from homework 2.2. (0.60x plus 0.40 times x minus 100 minus 100. When dealing with a problem like this, if you think of this kind of a decimal, think of it as money. You have 60 cents times x plus 40 cents times 100 minus x equals $1.20. So simplify the left side first. You can't do anything with this because you have to multiply first. Bring it down, 0.60x. And then we're going to distribute. 40 cents times 100 is equal to 40 because we're going to move the decimal a few times. So plus 40. And then 40 cents times negative x is going to be negative 0.40 x. Equals 1.2. We're not done with simplifying. We have two like terms. 60 cents times x minus 40 cents times x. So it's 60 cents minus 40 cents. So 0.20 x plus 40 equals 1.2. So now both sides are simplified. Leave x, since there's only one term of the variable, leave it here. I'm going to subtract 40 from both sides. So I have 0.20 times x equal to $1.20 take away 40 is going to be negative 38.80. $38.80. Okay. I know it's negative because the 1.2 is positive, and I'm taking away a lot more than that positive. No, the negatives are big. So you could just write up, it's going to be negative 38, 40 minus 1.2. But just make your answer negative. So now that the variable is separate from the constant, what do you do now? You divide by 0.2 or 0.20. Zero. And we get x is equal to, no, it's going to be negative because it's a negative. So think this through without a calculator. How many times does 20 cents go into a dollar? 5 times. And we have how many dollars? We have $38. And then we have an extra 80 cents. How many times is 20 cents going to 80 cents? So we have an extra 4 of those 20 cents. So we have 20 cents 38 times. So 5 times 38 is 150 plus another 40. So it's 190 of 20 of those cents that goes into the $38, plus an extra 4 of the 20 cents that goes into the 80 cents. So that's 194 times that this goes into that. Or you can move the decimal twice, if you multiply the numerator denominator by 100 over 100. So it's just 3,880 divided by 20. And technically, I didn't need to multiply by 100. Could have multiplied by 10 because that clears out the decimal. 388 divided by 2 is 194. But you have to be able to manipulate that fraction to see how it can work through. Or you just punch it in correctly. Three and four are kind of similar, but they have to be done in different ways, or they don't want you to get them confused as the same, that you can do the same thing to each one. And that's why I'm doing them in different order. I'm doing 38 before the 36. Step one, simplify both sides completely, but also undo fractions if you have fractions. Only have fractions. And you undo fractions by multiplying every term by the least common denominator. So over here, you have a 10 and a 5. What's the least common denominator? No. Here's why. If I multiply by 5, it undoes that fraction. But if I multiply this one by 5, 5 only goes, I still have a fraction. I need to multiply by the same number that's going to undo both of those fractions. 10. The first number they go into evenly is a 10. 10 undoes both of them. So the least common denominator is 10. So you multiply every term. Every term gets multiplied by 10. So this one gets multiplied by 10. This one gets multiplied by 10. And don't forget this one over here. Everybody gets multiplied by 10. Okay. Now, 10 goes into 10 evenly. So all we have left is 1 times x minus 5, which is just x minus 5. No more fractions. Minus 5 goes into 10 2 times, and we're left with 2 times this. So parentheses x minus 3. So I'm bringing it down so you see I have to do that distribution. Now, if you want to distribute up here, just don't forget that you have to distribute. I don't mind if you distribute from there and don't write this next step down, but you got to remember that that's what's going to happen. Even if it went in evenly, you still have a negative you would have to distribute. So you got to be careful with that part. And on this side of the we're still simplifying. We at least undid the fractions, but now it's a lot nicer to simplify. Before you can simplify, you have to get rid of the parentheses here. X minus 5, negative 2 times x is negative 2x. Negative 2 times negative 3 is a positive 6 equals 10. X minus 2x. What is x minus 2x? Negative 1x, or just negative x. 1x minus 2x is negative 1x. X minus 2x is negative 1. And negative 5 plus 6 is positive. So both sides are simplified. Get your variables on one side. Well, that's the only variable, so leave it here. Constant goes over to the other side, so you have to subtract 1. And I have negative x equals 10 minus 1 is a positive 9. You got to have that negative x there. Negative x equals positive 9. And then at the bottom of the box, it's not going to say, what's negative x equal? It's going to ask you, what is x equal? So this is not the answer. So what do I need to do that? Divide by negative 1. What you are seeing right here is negative 1 times x. When you have a negative in front of that x, it's negative 1 times x. Anything you would have a negative. Negative 5 is the same as negative 1 times a 5. Just like x by itself is actually 1 times x. There's a 1 in front of it. Technically, if you have a 5, you have a 1 times 5. There's a 1 in front of that. You don't write it because you would simplify. When you have negative x, you don't write negative 1 times x because negative 1 times x is just negative x. You simplify it. You always simplify. So when you have negative x equals 9, to undo that negative x, you divide by negative 1. A negative divided by negative is now positive. X equals negative 9. Time permitting, check your answer. But you want to check your answer in the original question. Maybe there was a mistake that you made here and got this answer instead of work in the original question. So in the original question, I'm going to plug in negative 9. So if I plug in negative 9 minus 5 all over 10 minus negative 9 minus 3 all over 5 is supposed to equal 1. What's negative 9 minus 5? So negative 14 over 10 minus negative 9 minus 3 is negative 12 over 5. It's supposed to make a 1. If I simplify this fraction, this is 2 times 7 over 2 times 5. So that reduces to negative 7 over 5. When I subtract a negative, what does that become? It becomes addition. So plus 12 over 5. What's negative 7 over 5 plus 12 over 5? Positive 5 over 5, which equals 1. If I plug in the answer I found, I get the other side, which is the whole point. The answer you get is supposed to make the equation true. And that's what we're trying to accomplish. We're trying to build the basics to handle real life. We're supposed to take really complicated life experiences, be able to write those life experiences with equations, with variables, assigned variables, come up with some kind of relationship between the variables of life so we can solve the problems. Not just solve them with, I think this works, but with mathematics that actually work. If you can solve it mathematically is true. It's not just sometimes, it's true because we have rules that we have to follow. Not theory. But you have to come up with the variables and the equations. These are the building blocks. There's a lot of truth out there. There's a lot of things people say are true. There's a lot of math that's made up to prove that it's true, but the math is made up so it doesn't work. Because we can make up statistics for a while. Now, here's why this one is not as straightforward as the next one. If you follow this step right here, it'll work with it. But what you can do over there, it doesn't work over here. Have you ever heard the words cross multiply? Cross multiply is actually a great term only under certain conditions. Sometimes people think this is cross multiply. 15 over 20 times 16 over 30. They think this is cross multiply. No, that's reducing common factors. That's not multiply. Multiply means I would have multiplied stuff. I didn't multiply anything, I reduced it. This was 15 times 1. This was 2 times 15. This was 4 times 4. This was 4 times 5. I reduced the 15, leaving the 2. I reduced the 4, leaving the 5. I didn't multiply anything. Plus, cross multiply means you go across something, like an equal sign. And that's what you have to do. Cross multiply means you have a proportion. A proportion is one ratio equal to another ratio. A fraction equal to a fraction. That's when you do cross multiply. You can multiply this way and get 25 times that x minus 5 and equal to, multiply that way, this x minus 3 times the 12. But remember, it's the 25 times the entire x minus 5. Friends, it's the entire x minus 3 times that 12. And you don't have any more fractions. But it only works because it's a proportion. Because you have one fraction equal to one fraction. I cannot do that right here. Because I have two fractions on this side and one number over here. I got these two, I have separate fractions. I could add them together. I could make one fraction. Then I could do some approximate. But you know what's simpler, quicker? Undo the fractions. Because it's not a proportion, I can't do what I just did. Undo the fractions. You know what? How I did the cross multiplying? I undid the fractions. That's how it works. Okay? If you undo the fractions, multiply everything by the least common denominator, that's what's going to work no matter what all the time. So let me show you how. Let me show you why. If you just stick with this, it'll always get you. X minus C. 25. X minus 5 over 20. So we need the least common denominator for 25 and a 12. Well, okay. 25 has to go into it, and then 12 has to go into it. You know, the first thing that they both go into is 25 times 12. Because 25 is only going to go into multiples of 25. 25, 50, 75, 100, 125. 12 doesn't go into any of those until we get to 25 times 12, which is 300. The least common denominator is 300, which is just 25 times 12. So I'm going to multiply by 25 and a 12. It's better to see it that way. That's the least common denominator. So over here, the 25 reduces, and I get 12 times that x minus 3 equals. Here, the 12 reduces, and I get that 25 times that x minus 5. So if you're not sure you can cross multiply, multiply every term by the least common denominator, and I'll get the same answer whether I could have cross multiplied or not. Least common denominator undoes the fractions. Okay. Distribute 12x minus 36 equals 25x minus 125. Variables on one side. Subtract 12x. Get negative 36 equal to 13x minus 125. Bring the 125 to the left side, add 125. Then we get 13x. And that's equal to 88. Right, so 89. And then you divide both sides by 13. That doesn't factor, so there's no common factor. Lowest. Your final answer, simplified, is 89 over 13. You can't just look at the problem and say, you know what, I don't want to do it, and skip it. You gotta do it one step at a time. You just gotta approach it with what you know. It's just step by step. First step, simplify both sides completely. So in this case, I'm trying to gather like terms. I can't gather like terms when I haven't multiplied things out yet. So I'm going to have to multiply x plus 1 squared to multiply this out. Now, if you know the special product, you can go straight to this is x squared plus 2x plus 1. And then distribute 2 times x, 2 times negative 2, that's minus 4, equals, multiply this out. You're going to get x squared minus 3x plus 2. Annoying, isn't it? But unless you ask, I don't have a clue whether or not you know how to do what I just showed you. So I just keep on going, go, oh yeah, they understand everything I just. Either you know how to do this using the special product, or you got to remember that you have to multiply it out. X times x is x squared. X times 1 is plus x. 1 times x is another plus x, and then 1 times 1 is 1. And then when you combine these like terms, x squared, 1x plus 1x is 2x in the middle, and then the plus 1. I haven't done that. Distribute the 2, 2x minus 4, and then over here it's just distribution. X times x, and x to the second. X times negative 2 is a negative 2x. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. So there's the x squared. Negative 2x minus x, that's negative 3x. And then the plus 2. Oh, plus 1. And you got to write the question down correctly because details matter. So that's going to be negative 2x, and that's going to be positive 1x. Negative 2x plus 1x is negative x. And that's going to be positive 1 times negative 2, so that's going to be minus 2. There. Thank you for saying something now and not like in 3 or 4 minutes when I'm way past it. Okay. So that's a piece of it. I'm still at simplify. Got to combine like terms on the left-hand side. So the only x squared is this one. But I have 2x plus another 2x, so that's a total of 4x. And then I have positive 1 minus 4. That's minus 3, negative 3. On the right-hand side, x squared minus x minus 2. Simplify completely. Both sides. Now, the x squareds. Section 4 and section 5. We are solving quadratics. We're solving problems that are x squareds. So you would get all your x squareds on one side. Look what happens though on this one. We go to get all the x squareds on one side, so let's bring them over here to the left. We subtract x squared and we subtract x squared, and there's no more x squared. That's because we're not in section 4, section 5, so we don't have to worry about it. We're in section 1 and 2, which is linear, which is x to the first. So now what we're looking at is 4x minus 3 equals a negative x minus 2. So now make a decision. Are we bringing x's to the left or taking x's to the right? So if I'm going to bring the x's to the left, how am I going to bring that negative x over here? You add x. You add x to both sides. 4x plus x is 5x. And negative 3 minus 3 still equals minus 2. Since we brought the x's to the left, what do we do next? So how do I undo that negative? Add 3 to both sides. 5x. Negative 2 plus 3. 1. So we separated the variable and the constant. We undo multiplication or division. This is 5 times x. What's the next thing? Divide by 5 on both. By the way, this is not dividing both sides by 5. I would like to know who showed you that so I can send over one of my friends that I don't have any actual paper trail or contact with. Happening. Divide each side by 5. So now you have x equals, and this is going to gotta make sure you understand. 1/5, 1/5, not 5. I see how did that just turned into 5s. You gotta have the 1 on the top. If you don't have the 1 on the top, it's not 1/5. If you think that 1/5 is the same as 5, I will give you 20 cents for your $5. Okay? If you think they're the same. It starts out really messy, but this is just simplified. Which I know you guys need practice with. My last semester students, they need practice with it now. Okay. It's the key to getting the question right. If you don't simplify before you start solving it, it's a mess. All right. So going back 43, 47, 54. Now, let me show you what's going on here. Pretty proud. So 2.1 to 2.2 part of the quiz. It's just solving equations. So the quiz prep you're going to get, solve the equation. Here's one with fractions. Here's one with decimals. Here's another one with fractions, but bonus level. First question from your test. Can you find the slope and the y-intercept? Bonus level. Be surprised how many people got this wrong. Or just couldn't even get started, which was ruined my day. And then look at this question. The volume of a pyramid with a rectangular base is equal to 1/3 x times y times the height. I didn't made that. I drew that. I didn't like cut and paste. I knew that. No. All you have to do is undo what's being done for the height. You solve for h. But in my experience, Give you a question that has something like this. Okay, solve for X. Give you a question that has got a lot fewer things in it, but it's got a B and an X and a Y. I'm out. Same steps, fewer steps. Actually, simpler than that, you can get done in one step. There's a picture, I'm out. It's got words in it, I'm out. It's a bonus question, I don't have to do it. Heck if I'm doing that. Take his bonus, shut up. So that's what you're going to see. I also want to just point this out. I'm also going to give you our post this. For 2.3, it's going to be a lot of square roots, cube roots, fourth roots, fifth roots. So here's a list of perfect squares, cubes, fourths, and fifth powers. 1 to any powers of 1. But the powers of 2 are going to be incredibly important. Powers of 3, you're going to see a lot of powers of 4, powers of 5. Powers of 6, at least through 6 to the third. That's a luxury. Powers of 7, at least through 7 squared, maybe 7 to the third. It's like I know of it. 8 is just a power of 2. So the answers for 8 are just 2's repeated. Okay? And 4s are powers of 2. So the answers for 4 are just 2's repeated. Powers of 9, 10, and so on. The more you know, especially the squares, you can undo perfect squares nicely. These are just, I was bored. In my brain next thing. But I'm going to post this so you have it. The more familiar you are with them, the better. How easy is it to get the powers of 10? Why is 10 to the 5th so easy to get? It's just the number of zeros. 10 to the 5th has 5 zeros. 10 to the 4th has 4 zeros. 10 to the 3rd has 3 zeros. 10 to the 12th would have 12 zeros. A 1 with 12 zeros. Which is why we as a country refuse to use the metric system, which is based on power of 10, because we like doing things more difficult. More ring a feet, a yard, and 5,280 feet a mile, 12 inches in a foot. But none of that metric system. So I haven't really got a workshop on material. 43 or 47, this is 2.1. 43, here's the area of a triangle. Area is equal to 1/2 base times height, solve for 8. Or 47, here's the volume of a right circular cylinder. Volume is equal to pi r squared times the height, solve for 8. Which one? Your bone. 47. So we have the volume of a right circular cylinder, which is pi r squared times the height. And we want to solve for the height. What is height? So a right circular cylinder is just a can. Pi times r squared. Pi r squared is the area of the circle times the height of the can. That's how you get the volume of most anything. That is it's got to be a rectangular shape. In this case, it's a circular shape, but it's the area of the base times the height. If it comes to a pinch, like a pyramid is, it's 1/3 of it. It's all about, from solving for whatever H is, undo what's being done to H. Well, H is being multiplied by pi and r squared. It's being multiplied by pi and r squared. So if it's being multiplied by pi and r squared, divide both sides by pi r squared. So pi over pi reduces, r squared over r squared reduces, you have H by itself. On this side, you have volume divided by pi. Height is equal to V over pi r squared. That's all you do. That's all we want. Undo what's being done to the variable in question. Then 54 is a work problem. And you have to do 53 on your homework, and they're done basically the same way. And on 53, I don't mind if you skip part A, write a verbal model for the test average of the course. You might want to read whatever they wrote. A store generates Monday through Thursday sales of $150, $125, $75, and $180. What do the sales need to be on Friday that would give a weekday average of $150? And the way that this is similar to number 53. To get an A in a course, you must have an average of at least 90% or 90 on your 4 tests of 100 points each. The scores on your first 3 tests, you have a 93, a 91, and an 84. So what do you have to get on the 4th test to get an A in the course? So you have 3 of your test scores. What does the 4th test need to be to get a 90 average? So here, what does Friday need to be to have an average daily sale of $150? How do you find an average of anything? Add up what you have and divide by. And so, and we're looking for something. So if for any given week, it's Monday plus Tuesday plus Wednesday plus Thursday plus Friday divided by 5 days. They told us Monday. Okay, Monday is 150. Tuesday is 125. Wednesday, 75. Thursday, it's 180. I don't know Friday divided by 5 days of the week. And we want the average to equal $150. You come up with whatever your life's problem is. You assign a variable. I'd like to know what Friday needs to be. So let's call it F. An equation that puts everything you have together with what you want so you can solve it. There's got to be some way to relate what you have with what you want. So far we've made $275, $350, $450, sorry, 100, 275, 350, 450, 530. We've made $530 plus whatever we get on Friday for 5 days, and we want 150 out. There's my equation. Like simplify it out. Oh no, it's got a fraction. What would I do to work with the fraction? Well, I wouldn't reduce it because I can't. It's got a plus in the top. Multiply by the least common denominator. Undo the fraction. And the only denominator is just 5. So I'm going to multiply this fraction by 5. And over here, you got to multiply by 5. No more fraction. 750. Now to solve for Friday, because 530 added to Friday, we just subtract 530. And Friday, we have to sell $220 to make a $150 average. Which, Fridays, nobody wants to go home. They're out doing things. Wednesday's slow day. But that's how you set up number 53. Any questions, sir? On 2.2, number 45 and 47 and 54. They are calculated questions. So use a graphing calculator to approximate any solutions for the equation. And I said, remember to write the equation in the form of f of x equals 0. So I'll talk about that. So looking at 45 or 47. 45 is 2x cubed minus x squared minus 18x plus 9 equals 0. 47 is x to the fifth equals 3x to the third minus 3. So which one do you want to see? 45 or 47? 45? So 2x to the third minus x squared minus 18x plus 9 equals 0. And just a quick sidebar here. On 47, the difference. In the directions, they say, remember to write it as a function and then let it equal 0. So it would be f of x is equal to 2x to the third minus x squared minus 18x plus 9. And then I'm supposed to let it equal 0 like you see right there anyway. So the good news about 45 is that it's already set to go. It's already equal to 0. 47 is 47, you can't plug in a left side and a right side into the calculator. Now, what I could do is I could let your first equation be the x to the fifth, and your second equation be 3x to the third minus 3. two separate equations, and then graph both of them on the same XY axis, and then make the calculator find where they intersect and find the X value where they intersect each other. That works. Or, like it says, make one side equal to 0. Bring this side, this 3x to the third, over to the left. Add 3, bring the 3 over to the left. So you have a positive x to the fifth minus a 3x to the third plus a 3. And you have one equation equal to 0. Which is what we need to be able to do for 2.4, 2.5. One equation equal to 0, we solve it. And equations. We're going to plug in y sub 1 is 2x to the third. 2x to the third power minus x to the third. X to the second power. And minus 18. And plus. And then I'm going to graph it, but I don't know what to set the window to. Right now, I have a trig window in there from last week. So I'm just going to leave the trig window. But I don't know what to set. I'm just going to graph it. Okay. Now the answers are the x-intercepts. When does this equal 0? Well, this is the y value. When does the function equal 0? So we're looking for the y-intercept. We're looking for those. Now, just so I can show you, here's what the actual graph looks like. You don't worry about this next one. So what I told the calculator to do is I told it to do a zoom fit. And what that means is it took the given x values and it fit the y to give me the entire picture under the condition of those x values. My x values went from negative 12 something to positive 12 something. Then I can see the whole curve in that value, in that window. So what I'm really looking, I really only need to see this much of the graph. Well, what's wrong? Well, I'm going to tell it to look at the negative 9, positive 9, and I only really need to look at the x-intercepts. So I just need to see right here between, let's just say positive 1 and negative 1. Because I have to find those. That's negative 6. Never mind, it's too high. Look at the Y values. They go from negative 383 to positive 326. That's a big chunk of Y's. I'm just going to change it from negative 2 to 50. Now, Y. Right. Just so I can see the intersection. This guy, that one, and that one. Then here's how you estimate. Don't use trace. Because if you use trace, you're not going to land exactly on it. You need to get exactly Y equal to 0. And I can't get exactly that. So right here above trace in blue is the calc button. So I got to go second, and then I'm going to hit calc. I get a menu. What do I want to find? I want to find the 0 of the function. Where does the function equal 0? So 2. Function number 2. Where do I want it to look? Well, the first one I want to find is this one. Now, when I set up my window, I set this from -5 to +5. So this first one, and these little notches are 1/2. So -1/2, 1, -1 1/2, -2, -2.5, 3, -3, -3.5. I'm just going to tell the calculator to look between here and here. So left bound is going to be -3.5, and on the right, -2.5. And I can just punch those in. So look in between -3.5 on the left, enter, and it gives me a little arrow above it. So right there, it's going to look in between there and -2.5. Do I want to guess? No, I don't. And it finds it for me. And it says the Y value is equal to 0 when X is -3. So that's one of the exit, or one of the X intercepts. That's one of the solutions. And then the next one, right here, X is 0. 1/2, and then here X is 1. So I'm going to have to look in between 0 and 1. Same thing, second, bring the calc. Option number 2 is find the 0. I want you to look between on the left, 0. On the right, 1. And no, I don't want to guess.
I'm going to have a whole quick deal with you.
And it happens at 0.5. And there's the last one. So there's 1, 1.5, 2, 2.5, 3, 3.5. So between 2.5 and 3.5. Don't assume that it's going to be 3. Maybe for this particular graph, it is 2.5. And 2.5. That's how you use the calculator. Now, this time it doesn't give you exactly 0, it gives you this. But it does say X equals 3. What is this number? Y equals -3, E -12. Perfect. That means Y is equal to -3 times 10 to the -12 power. That's had a special name. We'll have something scientific notation. That means it is negative 0.0000000003. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 12. Which is basically 0. Okay. But when you see this notation, it's scientific. And then number 47 or 454. I want to make sure you don't punch in absolute value. So we need 0 to be on one side. What do you think would be nice? To add 6. So if we add 6, we're going to get positive 6, and then we take away the absolute value of x minus 2. And that equals 0. That's what we're punching. Y sub 1 is going to equal 6 minus the absolute value of x minus 2. And by the way, if this were a chapter 1 question, it would be written y equals a absolute value of x minus h and then plus k. We would rewrite it as y equals negative absolute value of x minus 2. And that's a positive 6, so plus 6. What is the a? Negative 1, so it's going to go down. It's going to be a b term. What is the h? Positive 2, so it's going to shift to the right. Plus k. Positive 6, so the vertex is going to be at 2, 6. So it's going to be at 2, 6. And it's going to go down. So we should get x-intercepts right around there. Six minus the absolute value is right here with the math button. Hit math. And there's 4 columns. You have math, num, Swift, and proof. It's under number, which is the first option, absolute value, abs. Absolute value of x minus 2. So 6 minus the absolute value of x. And I was going to give us one simple little window from -5 to 5. And let's do a zoom shot. I'll give you one side, make it bigger. Now, 0. Left bound, and unfortunately, it's too low. And 0. So 1, 2, 3, 4. So I'm gonna have to look between -5 and -3. That's exactly a -4. And this other one, 1, 2, 3, 4, 5, 6, 7, and 9. In between 7 and 9. And this is just so you can get familiar with the calculator. You know where some few things are. It'll help. Editing. So that exit symbol over there on the left is that -4. This one over here on the right is an 8. So that takes care of 2, 1, and 2, 2. You have a prep coming your way for that. And then we will do 2.3, 2.4. Start it up on Monday. Don't forget tomorrow's last day for both questions.